All right, welcome to the third and final video for section 1 of chapter 2. So now that you've had a few examples of being able to identify transformations that have been made, let's actually look at doing the opposite. Let's take a function and apply some transformations and get our new rule or our new function. We're also going to look at being able to identify the vertex of a quadratic, of a parabola. So remember, vertex, you've got these U-shaped, these U's, or they kind of look like hills, these smooth curves, and these lines flow, they come to a point, and then they turn around and start going the other way. So the vertex is either the minimum or the maximum point on your quadratic. You should remember this from Algebra 1, but that's what your vertex is. So when we're writing quadratic functions, we actually have a form that we can write our quadratics in that is called vertex form. And vertex form is this form right here. What happens is you can write your quadratic in this form. And notice, this is just a form that includes all of the different transformations that we have. So we have y equals a times the quantity of x minus h squared plus k. This right here is vertex form for your quadratic equation. And from this, you get these values h and k. And h, k become, these right here are the coordinates of your vertex. So the point on the graph at h comma k is your vertex. So what we're going to do here is we're going to go ahead and take each of these transformations, apply them to our original function, and then we're going to write the rule for g in vertex form, and from that we're going to get the vertex. Okay? So make sure you have vertex form written down in your notes. You're going to need to know this. And let's go through the steps. We're going to do a couple examples of this, and then you're going to get to practice it. So let's look at the reflections or the transformations that we're making. So the first one right here, we're going to have a vertical stretch by a factor of 2. Okay? So remember, vertical stretch, that's where you're taking your entire function and you're multiplying it by an amount. And in this case, our a amount is equal to 2. Okay, so that's what we get from our first transformation. Our next, a reflection on the x-axis. Now remember, a reflection on the x-axis means that we are reflecting vertically, up and down, right? So that means that we're going to be taking the opposite of our function. Okay? So an x-axis reflection means that we're taking the opposite of our function, followed by a translation 3 units down. 3 units down is again going to be a vertical translation, and that means that we're going to be doing f of x plus k, and in this case we're going to be going 3 units down, so k is going to equal -3. Okay, so all I did right here is just as we went through and read all of these, I just wrote down each of the different transformations that we're going to have to make. So again, the first, we're going to be multiplying our entire function by a factor of 2. We're going to be taking the opposite of our function, and then we're going to be adding -3 to our function. So let's go through and do each one of these. So right here, this is just a summary of what I just wrote over here. The reflection in the x-axis in a vertical stretch, that means our a value is 2, and we're going to be taking the opposite. This is just combining the reflection and vertical stretch, and then moving 3 units down. So this is the first way. There's a couple different ways that you could go about doing this. So I'm showing you the first way to go ahead and write your rule based on these given functions. Next, what we're going to do is we're going to take these and we're going to plug these into vertex form. So we go ahead and write out vertex form of our function. So like I just wrote earlier, a times x minus h squared plus k. Let's just go ahead and substitute all of the amounts we have. So a is -2. Now in this case, we're not translating horizontally left and right. So h is just equal to 0. Okay, and we go ahead and plug in -3 for k. So now let's go ahead and simplify everything, and we get -2x squared minus 3. So all we did for this method is we just went through and identified each transformation, okay, and what these are in terms of a, h, and k, our constants, and then we just plug them into our vertex form. That's method one, okay? That's the first way that you can go about and get your new function. Let's look at another method. So what we want to do, that's taking everything and plugging it all in at once. The next step would just be to begin with a parent function and apply the transformations one at a time. And you have to make sure you do this in order. Okay, if you do this out of order, you may end up with a different rule. So let's just go ahead one by one and apply these. Okay, so first we want to go ahead and we're going to write a function that represents the reflection and the vertical stretch. Okay, so the vertical stretch by 2 and a reflection in the x-axis. So what that means is we're going to write a function that's just -2 times our original function. So remember, again, this is just like we did with linear functions. We write it in terms of our function symbol first, and then we plug in. Okay, so now we're just going to take x squared and plug it in for f of x, so we get -2x squared. Now remember, that's just applying our first set of transformations. Now we have to go ahead and apply our last one. So now we're going to go ahead, we've got our new function h, which just has the first 2 transformations applied. Let's go ahead and write a rule that represents the last translation. So now we're going down 3 units. So that's just going to be subtracting 3 from our function. And now again, we write it with function form first, and now we just substitute -2x squared for h of x, and we're going to get g of x equals -2x squared minus 3. So that's our transformed function. So that's how you go ahead and take different reflections and write your new rule. When it says write a rule for g, that's just writing your new function. Now I just want to show one last example before I give you your problems. Okay, in this example, our function that we were transforming was our parent function, x squared. But we can also apply transformations on functions that have already been transformed. So here, let's do the same thing we did again, except our function right here that we're going to be transforming is x squared minus 5x. All right, so here we're going to have our graph be a translation 3 units to the right and 2 units up, followed by a reflection in the y-axis. Write a rule for g. Okay, so we're making these transformations to our function f, which is x squared minus 5x. So let's go ahead. I'm just quickly going to go through this because we already saw how to do it, but I'm just going to show you how this differs when we're not working with our parent function. Okay, so again, let's go through and let's identify all of these. We're going to go through one at a time. So the first thing we're going to be doing is we're going to be applying our translations. So 3 units to the right and 2 units up. That means that we're subtracting 3 from our input, because remember, with horizontal translations, you take the opposite sign. So 3 units to the right is actually minus 3 from the input, and 2 units up means you're adding 2 to the output, or the entire function. Okay, so this is going to be our first change. So now, before we apply the reflection, let's go ahead and make these changes. So what we have to do is, what this means is we have to, for f of x minus 3, we have to take our original function and replace x with x minus 3. So everywhere there's an x, replace it with x minus 3. So see, we're going to, right here, we wrote this right here is our function f, right? X squared minus 5x, except we've replaced x with x minus 3. Okay, so that was our translation 3 units to the right, and then we're adding 2 to the entire function. Okay, so this is the first steps, applying our translations. Now, after that, what we want to do is we can go ahead and simplify this. Now, to simplify, all we did, you just take x minus 3 squared, so you just FOIL that out. So you get x squared minus 6x plus 9. And then distribute the 5, minus 5x plus 15, and then add the 2. So when you combine all those together, you get plus 9 plus 15 plus 2, that's 26. You get minus 6x minus 5x is minus 11x, and then x squared. So all we've done is we've just simplified. Now we have to apply our last transformation, the reflection in the y-axis. So now, remember, a reflection in the y-axis means that we are taking the opposite of our input. So our function g, we're going to take h right here. We're going to take this function, and we're going to replace, everywhere we've got an x, we're going to replace it with a negative x. So let's look at what that ends up being. So let's go ahead and rewrite it with parentheses. You always want to make sure you include your parentheses so you don't lose track of a negative symbol. Now, to simplify, remember, negative x squared is just negative x times negative x. That's going to give us positive 11x squared. Minus 11 times minus x, that'll be plus 11x, and then plus 26. So our final function is just going to be x squared plus 11x plus 26. Okay? So if you have any questions, please re-watch this. I don't want anybody coming in saying that you didn't understand the videos, but you didn't even try to re-watch them at all. You want to make sure you have your notes that you can look at, and you've gone back and looked at this multiple times if you need to go through the examples step by step. What I'm going to put up right now, I want you guys to go ahead and do numbers 7 and 8 right here. So in the text box, you're going to be doing what we just did with those two examples. For 7, you're going to write a new rule g that has these transformations to f of x, and then also write in the vertex. And then for 8, go ahead and just write in the transformations. Go ahead and enter those now.